Let us understand moment of inertia of different shapes along centroidal axis. This is the important data to solve the problems on centroid and moment of inertia. First shape is rectangle with base B and height D. We have to first select the centroid. So it is the center point. So we will select this. Now we have to show x-axis and y-axis passing through the centroid. So we will show here x-axis as a xc and y-axis as a yc because it is passing through the centroid. So what is the moment of inertia along this xc? So Ixc is equal to b d cube by 12 and moment of inertia about yc, Iyc is equal to db cube by 12. Now we will move to the next shape, that is the hollow rectangle. So here for larger rectangle, base is capital B and height is capital B. And for this hollow shape, inside it base is small b and height is small d. So we will first show the center. So center is here, or centroid is this middle point or center point. Now we will show this horizontal line as a xc and this vertical line passing through that is yc. So moment of inertia along this xc is known as capital BD cube minus small bd cube by 12 and moment of inertia along yc is known as capital db cube minus small db cube by 12. Now we will move to the triangle. Now for this triangle we have to select the centroid. So from this base, if we observe, we have to select the middle point and then at a height which is equal to h by 3. So this height is h by 3. So we have to select this centroid. Now from this centroid we will draw horizontal axis and vertical axis. So here is the horizontal axis is known as xc and here is the vertical axis is known as yc. So this moment of inertia along xc is bh cube, where b is the base, h is the height, bh cube by 36, and moment of inertia along this vertical axis Iyc is equal to hb cube by 36. Now we will move to the next circle. Now for circle we have to select the centroid. So centroid is its a center. Now from center we will draw two axes. One is xc and other is yc. Now for circle, moment of inertia along this horizontal axis and vertical axis is same. For this circle diameter is small d and therefore moment of inertia Ixc which is equal to Iyc is equal to pi by 64 d raised to 4. Next shape is hollow circle. For larger circle diameter is capital D and for smaller circle diameter is small d. Now its a centroid is the center point of these two concentric circles. Now we will show the axis passing through the centroid. So this horizontal axis is xc and this vertical axis is yc. So moment of inertia along this xc as well as along this yc is same for hollow circle. So Ixc is equal to Iyc is equal to pi by 64 in bracket capital D raised to 4 minus small d raised to 4. Now we will move to the next quarter circle. So for this quarter circle we have to first select its centroid. So we know that from this line and from this vertical line, from both of these lines this centroid is at a distance 4r by 3 pi. So we will first select this centroid. Now we will show the axis passing through the centroid. So this horizontal axis is xc and this vertical axis is yc. So for quarter circle also the moment of inertia along xc is equal to moment of inertia along yc. So Ixc is equal to Iyc is equal to 0.055 r raised to 4, where r is the radius of this quarter circle. So this is the formula. Now we will move to the semicircle. So for semicircle, we have to first select the centroid. So we have to first take the middle point of this diameter d. So we will select this, and then along this vertical line we have to choose the point at a distance 4r by 3 pi. So here is the distance. So here is the centroid. Now we will show the horizontal axis as well as vertical axis. Now moment of inertia along xc, Ixc is equal to 0.11 r raised to 4, where r is the radius of semicircle, and Iyc is equal to pi by 8 r raised to 4. Now if we observe here, this base is horizontal. Now in the next step, base is vertical. Then here is the centroid, that is along this vertical line we will select middle point, and then along this horizontal line we will select the point at a distance of 4r by 3 pi. Then we will show here xc as well as yc. Now we have to take the moment of inertia along xc exactly opposite to this, that is moment of inertia Ixc is equal to, we have to take the moment of inertia Iyc for this semicircle with horizontal base, that is pi by 8 r raised to 4, and Iyc is equal to 0.11 r raised to 4.